We're pleased to share with you today some really unique video coverage from last week's Ares 1X launch. A Cessna Skymaster aircraft flying at 12,000 feet in the vicinity of booster splashdown and equipped with a gyro-stabilized camera captured this video. This footage gives us some extremely valuable engineering data, as well as spectacular footage of the recovery sequence in rarely seen detail. First, a few words to preview what you will see after booster burnout, as some of the events happen quickly. First, you'll see the thrust plume diminish, followed by a brief flash, which is the firing of the booster deceleration motor, then a smaller flash on the side of the booster, which is the tumble motor firing. Then, after a couple of minutes of descent, you will see the drogue chute deploy to stabilize the booster tail down. Then the forward skirt assembly is jettisoned, and the drogue pulls it up and away from the booster. The three main parachutes follow immediately, and you will be able to see how one deflates, and the second remains only partially inflated. Right before water impact, if you look closely at the nozzle, you'll see the jettison of the nozzle extension, and then booster splashdown. Finally, you will see the drogue lowering the forward skirt assembly in a second splashdown event just to the left of the booster. The first stage flew very precisely and smoothly through ascent. Our primary interests on ascent included vehicle control margins, roll stability, and also an assessment of thrust oscillation. We saw very positive results with respect to controllability. The roll control system only fired 3 times during all of ascent, while our pre-flight analysis predicted as many as 20 firings of the rock system. So this is an excellent outcome. Also, we saw minimal vibration due to thrust oscillation, both in the data and from onboard cameras. The pressure oscillations from the Ares 1X booster were well within historical levels seen on shuttle flights. As the booster burns out, you see a flash during the firing of the booster deceleration motor. Then you see the firing of the booster tumble motor. The booster begins to rotate and separate from the upper stage. You notice also that the upper stage begins to rotate. This was expected, as the upper stage did not have a control system. In fact, the separation event for Ares 1X was more challenging than for the Ares 1 design conditions. Because we only had 4 segments of propellant, we burned out at a lower altitude and higher dynamic pressures, 90 pounds per square foot for Ares 1X, as compared to only 10 pounds per square foot for the Ares 1 design. So this resulted in a stress case separation and was very successful. One thing to watch during the descent of the booster is the trailing smoke from the nozzle. This helps us to see the flight path of the descent, which initially is horizontal to the Earth, and later, as the vehicle slows, will become more vertical. Early on in our engineering assessment for Ares 1X, we were concerned we might have a nose-first re-entry of the booster because of the forward-end weight of the 5th segment simulator. After several refinements to our weight and balance of the booster, we got our predictions down to only a 3% probability of a nose-first re-entry, which proved to be valid on our 1X flight test, as the vehicle stabilized nozzle down for most of the descent. Several oscillations can be seen in the booster orientation, and as speed decreases, the flight path becomes nearly vertical, as seen by the trailing smoke plume. It is interesting to note that during the vertical descent, there was a slow oscillation, and the booster is actually at about a 110-degree angle of attack to the flight path as the drogue chute deploys. This results in several dramatic oscillations under the drogue, but it performs beautifully, and the booster stabilizes nicely after about 4 oscillations. Watch closely at the top of the booster. The forward skirt extension is jettisoned and pulled away by the drogue. This entrains the risers of the 3 main parachutes for their initial inflation to the reefed or partially inflated position. All 3 chutes make it to the first inflation position, but the chute on the left quickly deflates and fails, trailing a streamer which appears to strike the chute in the middle, perhaps damaging it as well. So just prior to water entry, we essentially have 1.5 chutes suspending the booster. Also at this point, you can see the nozzle extension pyrotechnically severed at the bottom of the booster just before water entry. The booster hits at a higher velocity than planned, which causes a hard slapdown and buckling of the aft segment motor case. This has also been experienced in the shuttle program. A total of 11 chute deployment failures have occurred in the life of the shuttle program, most recently on STS-128, so we have abundant data to resolve this for future missions. Ares 1X was also a parachute stress test, as the booster was nearly 40,000 pounds heavier than an Ares 5-segment booster due to the hardware in the 5th segment simulator. The parachutes were a world record-setting 150-foot diameter and were tested at a total payload weight for the first time during Ares 1X. Now that the booster is down in the water, watch for the drogue and forward skirt extension to enter into the image just to the left of the booster. All of these sequences worked exactly as designed. Today, the booster is on dock at Cape Canaveral and is undergoing teardown inspections. In the next few days, we'll be able to recover the data recorders and begin the detailed data analysis of the entire flight.